Okay, so here's another question, and says we have this reaction. It was studied at 25 Celsius. It's always 25 Celsius. And they give us a rate, and here's our concentration of iodide and this thiosulfate. So what are we going to do? And you don't need to know the name of that. So I see here in this experiment, I'm just going to number them 1, 2, 3, 4, 5. Here in experiment 1 and 2, this S2O8 was held constant and this was doubled. So I'm going to compare experiment 1 to experiment 2. So it's going to be rate for 1 over rate for 2 is going to equal 0.80. I need another 0 in there. 0.040 is going to equal 2.5 times 10 to the negative 6 divided by 6.25 times 10 to the negative 6. And that is going to be molar per second, and this is molar. As you can see, all of our units are canceling out, and I'll put this as x, and so I get 2 to the x equals 2, so x equals 1. So now let's do the same thing for iodine, and it looks to me like I could use experiments. Let's see, this one and this one, they're held constant. This one, but this doesn't double, does it? What is that factor? Well, let's figure it out. Let's go ahead and put in experiment 4 with experiment 1. So I'm going to take experiments, and this one's bigger than that one, right? And so I'm going to put experiment 1 over experiment 4. So that's going to equal concentration of 0.080 over 0.032. And all this is raised to the y. It's going to equal 1.25 times 12.5 times 10 to the negative 6 over 5.00 times 10 to the negative 6. And so in this case, I'm going to go ahead and use my calculator. 0.08 divided by 0.032 equals, that's 2.5 raised to the y is going to equal 12.5 second EE negative 6 divided by 5.00 second EE negative 6 equals, and we get 2.5. Notice these are not easy numbers, but once we get to here, it comes out to an easy number. And what does y have to equal? Well, y has to equal 1. So my rate expression is going to be rate equals K times the concentration of, what do I have here? I minus times the concentration of S2O8. I think that's 2 minus. Yeah, 2 minus. And now, how would I figure out K? I would just put in values for each of these to figure out K. And in fact, they're asking you to figure out K for each and every experiment, and it should come out to a constant or fairly close. I'm not going to run through that. We've already done one of those, but I wanted to show you one where it doesn't necessarily come out to or some whole number, but eventually the math should be fairly simple. Okay, thanks for watching.